Here we've got another example where we're solving a trig equation and there's a sine squared theta in there. So just remembering that that means sine theta all squared. So we've actually got here, you might be able to see it, you could imagine that, if that was, instead of being sine theta all squared, it's x squared and that's x, it would look just like a regular quadratic, wouldn't it? So we can solve this using just the same principles we do for quadratics. So for this one, it's not mnemonic, so I'm going to do a bit of grouping. I can see that if I split up that middle term, I just change it to blue. If I have 2 sine squared theta, it's just 2 sine squared theta plus sine theta plus, let's just get rid of that. Plus 2 sine theta, just splitting up that middle term so I can do a bit of grouping, looking at the first 2 terms and then the second 2 terms separately, kind of factorize them in pairs. If I take out sine theta from this, and I'm left with 2 sine theta plus 1, then I'm going to, if I factor out just 1 from this, plus 1, 2 sine theta plus 1 equals 0. Then I can factor out that term in brackets there. So 2 sine theta plus 1, all in brackets, times by sine theta plus 1. And I got myself a factorized thing where I've got just these linear terms, so to speak, terms together equaling 0, so I can do the null factor law. And I get, well, I think about this, to make this 0, sine theta would have to be equal to minus a half. And here sine theta would have to be equal to minus 1. And so now in terms of solving them, so what? When is sine theta a half? I think it's, what are we doing? We're doing radians. So if I just draw my little triangle here, root 3, 1, 2, what's this? It's going to be, it's opposite over hypotenuse, right? So it's got to be this one, which is pi on 6 in there. So, but it's when it's negative, so I put out my cast rule, C-A-S-T. So it's going to be negative there and there. So that's going to be theta in this just one revolution, could be pi plus pi on 6, so 7 pi on 6. And 2 pi minus pi on 6, so what's that? 11 pi on 6. And then here, when is it equal to negative 1? Well, the only place it is in one revolution is down here, isn't it? So about 3/4 of the way around, which is the angle for that is 3 pi on 2. So in terms of the values of theta that solve that equation for this domain, well, it's just all of those things written together. So it's nice to write them in order. 7 pi on 6 in terms of, ascending order. 3 pi on 2, 11 pi on 6. Cool. So that is that one done. And those should solve that. So we go, there are all our values there. Now, here is a more complicated example. And what is a bit tricky with this is we've got both tan and sine. So it's a bit less obvious how we might factorize this. But I can kind of see that, tan theta plus 1, if I look here, say I were to take out a factor of 2 sine theta, again, I could do a bit of this grouping. So if I take out 2 sine theta, I'm left with here tan theta plus 1 is equal to tan theta plus 1. And then if I were to subtract this, then I get 2 sine theta times tan theta plus 1, take away 1 times tan theta plus 1 in brackets. So I've just written it in brackets there so I can see that really now I can factor out that tan theta plus 1 and be left with another term. So here's my first term, my first linear term, and then 2 sine theta, take away 1 is equal to 0. And now I can use my null factor law and just solve these two equations. So one of them is tan theta equals minus 1. And the other one is, the alternative is what? Sine theta equals positive a half. So because I just did that example, I remember that that's when it's pi on 6, and it's either going to be what? There or there, because of CAST. So what? Pi on 6 or 5 pi on 6, yeah? For tan theta equals minus 1. So what? We would need, just remembering that tan theta is equal to sine theta and cos theta. So what do we need? We need sine theta, well, what could it be? When would it be? Oh wait, no, we don't even need this. We can just use our exact values triangle, as always. 1 on root 2, 1, 1, 1, root 2, pi on 4. Using that one. And so what? Tan is opposite over adjacent, so it's 1 over 1, but we need it to be negative. So it needs to be in the sine quadrant and the cos quadrant. So it'd be, let's just change color, pi on 4 up there, pi on 4 there and there. So it'd be 3 pi on 4 or what, 7 pi on 4? I believe so. 3 pi on 4, 7 pi on 4. So then we've got our solutions are these as well as these. Would solve that equation, would make that equation true in that domain. We found all the possible values. And there you have it.